So, hey, I just thought we'd look at some of the 3.1 homework just to kind of see what's going on here. So in the 3.1 homework, this is where we were looking at doing degrees and radians on the circle, and then also looking at arc length and area of arcs or sectors in a circle. So first, let's look at converting the angles to radians and just kind of remembering what that formula is. So let's see what that is. Okay, so remember kind of how this works, converting back and forth. If you've got 300 degrees and you want to convert that over to radians, you know it's going to have 180 and pi in it. So just kind of remember those. And you just need to set it up so that the degrees cancel, kind of like unit conversions. So to go from degrees over to radians, you're multiply by pi over 180. And again, just kind of something that reminds you of that is then those degrees cancel. So you get 300 pi over 180, and then we just want to reduce that down. So what is that? 30 pi over 18, and 6 goes into both of those, so 5 pi over 3. And so question number 2, you're going the other direction, so 4 pi over 3. And we want the degrees on the top this time because that's where we're going to end up. Okay, so notice in this case those pi's cancel out. Just keep in mind that a radian measure doesn't have to have a degree in it. So it looks a little weird, but you could have, say, 4/3 radians. So you can't just think about the pi's here. You would still multiply that by 180 degrees over pi. So it's really about introducing that degree. So anyway, back to this. So now we've got 4 times 180 degrees over 3. Let's see, 3 goes into that 60 times, 6 times 4, so that's what, 240 degrees. So let's see if there's any kind of tricks here for putting these kind of answers in. So 5 pi over 3 and 240. So here I'm just going to do 5 pi slash 3. So there's 5 pi over 3. And then here I'm going to do 240. And you don't need the degree symbol because you see here at the end of the box it says the word degrees. So that's letting us know that that we're doing that. Okay. So there's our answers there. So this one, or these two really, I guess, we're looking for coterminal. So remember, looking at an angle, for them to be coterminal, the idea is to kind of think of them in standard form. So like this would be a 45-degree angle. And this is called the terminal side of the angle. Okay, so the angle is this part right here. So notice if I were to go, say, cheating here, 360 and 45 makes 405. If I were to, again, start here, let me do that in a different color. If I were to start here and go 300 or 405 degrees, then my terminal side would end up in the same place. So these are called coterminal. So if you're in radians, what you can do is just take your value and add or subtract 2 pi's, right? Because one whole circle is 2 pi. And you know, if you go 2 pi forwards or backwards, you end up at the same place. If you're talking about degrees, it's going to be a circle is 360 degrees. So you can just add or subtract 2 pi if you're in radians, or add or subtract 360s if you're in degrees. So let's just look at this first one. Now it does say it wants the angle to end up being between 0 and 360. So if I start with 1588, I can just start subtracting 360s. And actually I'm going to go ahead and do 720 because that's 2 of them. Blah, 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 8 minus 2, 15 minus 7. And oh, I can do another 720 degrees. So I just subtracted 4 circles total. and I end up at 148 degrees. So this will be 148 degrees. And then for this one, we've got negative 1654. Let's just start adding circles. And I guess 1440 would be 4 circles total. That's these two added together. So 7 and 7 is 14. All right, so remember, when you're adding integers, if one's negative, then what you're really doing is subtracting and then keeping the sign of the bigger number. So we're at negative 214. So we just need to put on one more 360. And that puts me at 56 degrees. So that would be 56 degrees. And then also, again, notice that at the end of the boxes, they have the word degrees, so you don't actually have to put the degrees in there. So let's just keep going. So this is the same thing, but in radian. So just make sure you get a common denominator there. So we've got 69 pi's divided by 10, and I'm going to subtract 2 pi. So notice 2 pi with a 10 on the bottom would actually be 20 pi, right? So this is the same thing as 2 pi. So we're going to subtract off some 20s. I can go ahead and do another one. And another one. Oh, whoops. I don't know why I put that over 100. So I'm just subtracting off a bunch of circles. And 69 minus 60 would put me at 9 pi over 10, which I don't really know what that angle is, but it's just before pi, right? So this would be 9 pi over 10 right there, because this is 10 pi over 10. So there it is with degrees. Add or subtract circles, just make sure you get a common denominator there. I forgot that I had the camera going. Okay, so let's look at this next one is looking for a circle of radius, sorry, it says a circle of radius 7 miles. We want to try to find the length of the arc that subtends a central angle of 3 radians. So in a circle, we actually learned that if the radius of the circle is just 1, that if this was, say, pi over 4 length, then the angle is also pi over 4. So in the unit circle, so sorry, the length of an arc is actually the same as the angle. But the formula is actually like this, where the arc length is equal to the radius times the angle, and that angle has to be in radians. So in the unit circle, the radius is 1, which is why the arc length and the angle are actually the same. But we're going to use this formula, and we just need to make sure that we're in radians. So in this picture, my circle has a radius of 7 miles, and it says the central angle is 3 radians, which is just shy of pi. So this is 3 radians. We want to know what the length of this arc is. So that is S. So S is equal to R times theta in radians, and it told me that it's in radians. So this is going to be 21 miles. And again, notice it already has the miles on there, so you would just have to put the 21 in. Okay, so let's look at the next one. Goodness gracious. Okay, so distance along an arc on the surface of the Earth that sometimes a central angle of 9 minutes. where 1 minute is 1/60th of a degree. It says the radius of the Earth is 3,960 miles. So we want to find the distance along that arc. So I know the Earth is technically a globe, a sphere, but we're just thinking about the circle of it. It says the radius is 3,960 miles. It's asking about a central angle of 9 minutes. Now we're about to have to do a little bit of conversion. So remember, or sorry, an angle of 9 minutes. This has to be in radians when we put it in the formula. So I need to try to convert this over to radians. Now what it told me was that 1 minute is 1/60th of a degree. But we don't want degrees. So we know that 180 degrees or times pi puts me in radians. Okay, so this would be radians if you want to put the measure on there. So notice if we multiply this, the minutes will cancel and the degrees will cancel, divide out. So let's see what this is actually going to look like. We're going to have 9 times 1/60th times pi, and then divided by 180. I'm going to write that as times 1/80, just so we can see that. So 9 times 1/60th times pi, and then that whole thing is divided by 180, so times 1/180. So we can actually cancel this, reduce this down a little bit. So the 9 and the 180 would make a 20. So we have pi over 6 times 2 is 12 with 2 zeros. So here is the angle in radians. So I don't really know where that is. Let's just pretend like it's right there. So this is pi over 1200, and we're trying to find the length of this arc. So same formula, S is equal to R theta. So an exact answer, I don't even know here. Pulling out my calculator. So 3960 divided by oh, that doesn't look right. What did I just do? Oh, someone's coming. I'm recording. All right, so 3960 divided by that. I don't know why I'm getting such a weird answer.
Are you live right now?
Yes, I'm live right now, Quinn.
Hi, I'm sorry.
I'm getting a very strange answer here for some reason. So 3960 divided by that answer is 3.3 pi. So times pi. So I'm getting 10.3. Oh, yeah, something's really off. 10.37 miles. That can't possibly be right. So let's just see what we did here. So 9 minutes, it says 1 minute is 1/60th of a degree, right? So 1 minute is 1/60th of a degree. So if we were to multiply this by 60 over 60, I'm just trying to make it look better. That would be that 60 minutes is 1 degree. So let's do this. I don't know what went wrong there. So we have 9 minutes times, all right, so 60 minutes is 1 degree. And then over to radians, there are 180 degrees, so pi, in pi radians. So the minutes cancel and the degrees cancel, and we get 9 times, I'm going to go ahead and abbreviate it. Maybe this will make more sense. Abbreviate, approximate, estimate. All right, so 9 times pi, all right, divided by 60 times 180 is equal to, okay, so this is a very small number. This is 0.002618. Okay, so this is a tiny, tiny bit right here. So now our answer makes more sense. So if I were to take this and just multiply it by my radius, so times 3960, we do get this answer. Okay, so this answer was perfectly fine. I just did a bunch of stuff for absolutely no reason, and I apologize for that. But it does say 3 decimals, so 10.367 miles. Again, it's so small because the angle was so darn small. So 10.367. So I apologize. Well, look, you just saw it kind of twice. So 10.367. It already has the word miles on it, so we don't have to do anything there. Yay, we got it right. Okay, so this one says on a circle of radius 6, what angle? So this one is still using that same formula, S equals R theta, but this time they gave me the radius is 6 feet. So there's the radius. It gave me the length of the arc is 3. And so notice we're actually having to solve this for theta. So we'll just divide both sides by 6. So theta is equal to 1/2. And remember, this is in radians, okay? So see, they're trying to trick us because they ask for degrees. So 1/2 radians, to convert that to degrees, it's going to be 180 degrees over pi. So that is going to be, so they are asking for degrees. So we're going to do, let's see, 180 divided by my 2 pi. This is approximately 28.648 degrees. So let's try that. If that doesn't work, we'll just put 90 over pi degrees, but it doesn't say how to write the answer. So I'm going to, you know what, I might do the 90 over pi. I'm going to do that one first. So let's just try 90 over pi. And it already has the degrees on it. Okay, so it was fine with that. Just for the heck of it, let me put in the decimal and see if it would accept it. So 28.648, that's in degrees. So again, remember they were kind of trying to trick us, and that was fine too. Okay, so it didn't specify and it didn't care. All right, so let's look at question number 9. So this one wants the area for the sector of a circle. So this time it's the same kind of thought, but we have to remember that area is actually equal to r squared, well, 1/2 r squared theta. So, and that actually just comes from the area of a circle. So the area of a circle, everybody knows and loves to be pi r squared. But we don't want the whole circle, right? We want a piece of the circle. So this would give me the entire circle, and I just want a fraction of it. What fraction of the circle do I want? Well, this is theta. The whole thing is 2 pi. So the fraction of the circle I want is theta over 2 pi. So notice what happens here. The pi's cancel, and you get 1/2 r squared theta. So that's where that formula comes from. But so this is how we're going to find the formula for our sector of a circle. All right, so in my beautiful picture that I have here, well, here, let's get rid of that. So we're looking for, we've got a circle, it's got a radius of 8 meters. I want a central angle of 290, and that would be, blah, blah, 70 shy. I mean, that's almost the whole circle. So they want the area of all of this, okay? Notice, though, this is in degrees. This is radians, okay? So the formulas are always radians, so we're going to have to convert that over. So let's check out our formula. So we've got that area is equal to 1/2. Radius is going to be 8 meters, and notice the answer will be in square meters. And then 290 is the angle, but that's in degrees. So I need it in radians. And you can do this as a separate step too. I just kind of put it all in one. But notice then the degrees will cancel and I'll be in radians. So 8 times 8 is 64, divided by 2 is 32. And then 290 over 180. So this is times 29 over 18. I guess it, pi. I didn't mean to actually put that in the calculator. And 32 times 29. Okay, so this is 464 pi over 9. So there's our actual answer, 464 pi over 9, and that's in square meters. So I'm going to put it in that way just to see how it feels about it. So 464 pi over 9. Oh, well, never mind. I didn't read. It says very clearly right here it wants it to 2 decimal places. So let me do times pi in my calculator. And this is 161 point. It's 966, so that would make it 97. And that's in square meters. All right, and then the last question here is asking about our speed. Okay, so it says a truck with a 42, I like using the thicker one here, with a 42 diameter wheel. Okay, so the whole thing is 42. That makes this, the radius, 21. And it says that it's traveling, so its regular speed, which is velocity, is 50 miles per hour. Okay, so it's linearly going 50 miles per hour, but I want to try to figure out the angular speed. Okay, so it says find it in radians per minute, and then, oh, that's it. And then how many revolutions would it make? Okay, so we had a nice little, I was going to use the formula that related them instead of going the long way around, which is the way I know how to do it. So let me just, I forgot the shorthand, and instead of deriving it for you, let's just glance at it. There it is. So if you recall, like the very last slide in here, we had kind of that shortcut that just related the two together. So we're going to look at this one. So it says that velocity is just equal to, radius times angular speed. So I don't know if you recall, I kind of showed how those were related to each other, and it takes a little bit of substitution, but this formula makes sense. You've got velocity, just multiply it by the radius times the angular speed, and you'll have everything. So velocity is equal to radius times, that is omega, which is angular speed. So oh my goodness gracious, V is equal to r theta. What happened to my, there it is. Okay, so we're going to use the formula that says that V is equal to r omega. I said theta. Okay, so we know that velocity is 50 miles per hour. Okay, we know that radius is 21 inches. And then here's what we're going to solve for. So notice that our angular speed is simply going to be the velocity divided by the radius. But this is going to be weird because velocity is in miles and radius is in inches. So we're going to have to change some things here. So let's, now we could actually do it either way. We could change miles to inches, or we could change inches to miles. In the hint, it says to convert the miles over to inches. So let's just focus on that velocity for a second. 50 miles in 1 hour times. There are 5280. I was just doing that backwards. 5280 feet in 1 mile. All right, so my miles will cancel. I am now in feet per hour, but I know that there are 12 inches in 1 foot. So now my foots cancel. My foots cancel? That makes perfect sense. And we can see, let's see, 50 times 5, 2, 2, times 12. Whoa, this is big. Okay, 3,168,000 inches per hour. So this is how, oh crap, we want to be in minutes. So now we got to go one more time. Let's convert this over to minutes now. So we've got 3,168,000 inches over 1 hour. We could have done this all in one if I had had more paper here. But 1 hour has 60 minutes in it. So I'm just going to divide this by 60. And we have 52800 inches per minute. All right, so now we are in inches per minute. So again, we're using this formula. So our angular speed is simply the radius, which is 21 inches, divided by, I just said that backwards. So our radius is, or sorry, our angular speed is velocity, which is 52800 inches per minute. And then we want to divide that by radius, and dividing by a number is the same as multiplying by its reciprocal. Notice the inches are going to cancel. So I'm going to divide that number by 21, and I get 2514.286. This is in radians because it's automatically in radians, and this is per minute. So this is going to be our answer per minute. And then to figure out how many revolutions that would be, well, how many, well, again, this is another conversion. So well, we are at 2514.286 radians per minute. And we want this to be in revolutions. Well, how many radians are there in 1 revolution? There are 2 pi, right? It's a circle. So we're just going to divide our answer by 2 pi, and I'm just doing this in my calculator. So I just did that answer divided by 2 pi. So now, you see this is radians. So now our radians cancel. We're in revolutions per minute, or RPMs, and this is about 400.161. All right, so that was a lot of conversions. But again, I could have put this just at the end right there, and then it would have come out really nice. I just didn't have enough room. So let's put this in. So we came up with 2514 point. It didn't tell me decimals. I'm going to do 3 to be safe. I'm going to go 28. It was 57, so 286. And then we just divided that by 2 pi to get rotations. So that's 400 times 161. Oh, that's good. Yay, we did it. All right, and that is the end of 3.1 homework. Sorry, I can't find my mouse. I'm looking at all my screen.